All right, hello everyone, and thank you for having me here. I'm Dr. Nick Pennings. I'm the Chair of Family Medicine at Campbell University School of Osteopathic Medicine. I'm a family physician and obesity medicine specialist, and I did private practice for 22 years and then went into teaching, and I wanted to teach so that I could share my knowledge with my students. One of the things I didn't realize is how much my students would teach me, because one of my students taught me about a condition that I had never heard of called lipedema. And even though I was board certified in obesity medicine, I had not even heard of that. And that really opened a door for me to really study and learn more about this condition and hopefully be able to make a difference in this field. So I wanted to talk about this topic in part because it gives you a foundation for what I'm going to be talking about next, and in part because it's very misunderstood that the general perception that all body fat is bad and that body fat is unhealthy. And so, is body fat bad for your health? Well, to an important degree, it's not, and in some degrees, it is. And one of the ways I explain this is looking at these two individuals, which one is more likely to develop type 2 diabetes? And I'll ask this question to health professionals and medical students, and you first look at this and think, well, A, doesn't have any body fat, must be healthy, must not be very high risk for developing diabetes. The person on the right has a significant amount of body fat, and you would think would be at risk for diabetes. Actually, it's not. The person on the left has something called lipodystrophy. Lipodystrophy is a condition where you can't form body fat. And when you can't form body fat, what happens is any excess calories now have to go to the liver where it's turned into circulating body fat or causing insulin resistance, and these patients develop diabetes and heart disease at a very young age. In fact, this person's only 29 in this picture, and yet looks much older than that. Unfortunately, many of the healthcare professionals don't recognize the condition on the right, but of course, everybody here recognizes it as lipedema. And I see many patients with lipedema. Very rarely does anybody have diabetes. So just going to give you a little kind of better understanding, hopefully, as to why that is and what those why patients are less likely to develop that. So we're going to kind of go through a little bit of what happens to calories when we eat. And this is when we eat calories, we consume carbohydrates, we consume proteins, we consume fats. The carbohydrates are mostly converted into glucose, which we either going to use right away, we're going to store in our liver or muscles as something called glycogen, which is a pretty readily available source of energy for our body. And any excess is going to go then to the liver, and then it gets turned into fat, where it's stored either mostly in subcutaneous fat tissue or in muscle. Fructose and galactose have different pathways. They have to go through the liver and turn into glucose, but can eventually be turned into fat as well. Proteins we consume, and they go to the tissues in our body. But if we consume too much, then that gets converted into sugar, which eventually can be converted into fat as well. And then when we consume fat, we actually use some of that fat right away for immediate needs, and excess goes into subcutaneous adipose tissue. So this kind of just gives you a general view of what happens when we eat. Our food gets converted and either used, stored as glycogen, or stored as body fat. But we have a limited capacity to store body fat in the subcutaneous adipose tissue. And when we exceed that capacity, then our body then starts to develop something called insulin resistance. And that's what leads to diabetes. And so insulin resistance, when that starts happening, that excess fat has to go to different areas of the body. It's going to go into dysfunctional adipose tissue, subcutaneous adipose tissue, and go into the viscera around the abdomen. It goes into the liver. It goes into other tissues, into the muscles and around the heart and kidneys. But that's where all the metabolic dysfunction comes from. That's where the heart disease comes from, where the diabetes comes from, where the metabolic disease occurs. But what happens in lipodystrophy is that capacity, that subcutaneous adipose tissue, is very small. And so it very quickly turns into dysfunctional adipose tissue and very quickly turns into insulin resistance and all the health consequences that go with that. With lipedema, there's a great capacity to expand that subcutaneous adipose tissue. And that subcutaneous adipose tissue does not have those same unhealthy metabolic effects, which is why when I see patients with lipedema, I rarely see diabetes, don't usually see high blood pressure, you don't see high triglycerides, you don't see low HDL, you don't see any of those metabolic disturbances that we typically see. What you do have, though, is an increased amount of dysfunctional subcutaneous fat that is not that is going to be inflammatory and painful, and that's where some of that origins of that comes from. The other concept that I think is important here is that where fat is or where calories are stored when we eat them and where we go for them when we are not eating, when we're in a calorie deficit, is not the same place. So if you eat an excess amount of calories, you can very effectively store that into your subcutaneous adipose tissue, but when you calorie restrict, it doesn't mean that the calories are going to come out of there. They're going to come from other places, and this is sort of the cycle that builds with lipedema. And so we can see with calories, we're either going to use them right away, which is sort of the top tier of that fountain. We're going to store them as glycogen, which is smaller. And then we have the larger disposal at the third tier of fat storage. And then beyond that, we have that dysfunctional fat tissue. So we often thought of body fat as just, historically, it just is a cushion, it provides insulation, it stores energy. But really what it does is it plays a very important role in regulating our appetite, in helping either prevent metabolic dysfunction or cause it, and inflammation. And really it's a very active endocrine organ. So the adipose tissue can be beneath the skin, it can be around the internal organs of the body, can be in the bone marrow, or it can be embedded in the organs in something like non-alcoholic fatty liver disease, or even with heart disease. We can see heart failure associated with fat being deposited in there. And so we have different types of adipose tissue. We have white adipose tissue, which can be the subcutaneous fat that we talked about that doesn't have a lot of metabolic dysfunction, or we can have visceral fat, which has a high impact on metabolic disease, and they have different pathways. But there's also something called brown fat, and you may not be familiar with brown fat. That is something that plays an important role, and we can convert white fat to brown fat. So sometimes called baby fat, and it's brown because it's very dense with mitochondria, the powerhouses of the cell, and these generate a lot of heat. And we see this in certain individuals, and this may explain the people that seem to be able to eat a lot but never gain any weight. We all hate those, right? They are more likely to have higher levels of brown fat, which sounds like, well, that sounds like a great thing. How do I get some of that? And one of the ways to get that is cold exposure. So when we expose ourselves to cold temperatures, we actually stimulate brown fat formation. So we have lots of white blood cells, white fat cells, 30 billion adipocytes. They can increase in size fourfold. They can divide, and so we can form new fat cells. They're filled with triglyceride, which is the fat that's whole. But what really is important about the tissue is its role in appetite regulation, that it produces leptin, which plays an important role. It's a satiety hormone. It makes us feel full. It also produces adiponectin, which has a role in inflammation in the body. as well as cytokines, which cause inflammation, and there's a lot of different other activities that we won't go in today. But leptin is important. It was first discovered in '95, and the more adipose tissue you have, the more leptin your body produces. And leptin, as I mentioned, causes satiety. Well, that sounds like it would be really helpful, except when we find that people that have high levels of body fat also produce lots of leptin, but it doesn't seem to have an impact on satiety anymore. And that is thought to be due to something called leptin resistance. Adiponectin is really very interesting. It too is produced according to body fat, but actually in the opposite way. So as your body fat increases, you produce less of adiponectin. And adiponectin is an anti-inflammatory agent, so it really has a lot of benefit. It stimulates fat breakdown, it improves insulin sensitivity, and decreases inflammation in the body. And so we need more adiponectin, and that's a challenge. So how do we regulate this body fat? Well, we are actually continuously turning over our body fat in a process called lipogenesis and lipolysis. So it's constantly turning over in our body, and the thing that regulates this is insulin. Insulin doesn't regulate just glucose, it actually regulates protein, it regulates fat in the body, and it regulates our appetite. It has a central satiety effect in the brain. So it plays an important role, and this is where what happens is that when insulin is inhibited, then it keeps the body from breaking fat down. And when insulin resistance develops, then the fat is more likely to be released from the fat cell. So with insulin resistance, where you're going to release more of this fat, which is going to cause your glucose to go up, it's going to cause you to develop insulin resistance, it's going to cause you to develop triglycerides, it's going to cause the good cholesterol to go down. That's where metabolic disease occurs. But in tissues that are very sensitive to insulin, meaning that insulin is working well in them, opposite of insulin resistance, the adipose tissue is going to not undergo lipolysis. So in effect, that insulin plays an important role in storing fat. So glucose doesn't go up, all those metabolic parameters are normal. And I think this plays an important role in lipedema because in lipedema, the body fat is stored very effectively, but very slow to be released. And so what we look for is to develop healthy adipose tissue, and we do that from forming healthy adipocytes, and those will have good blood flow to them and not be overly enlarged. But when they are unhealthy, when they're too large, when there's not enough of them, they don't have good blood flow, then you get inflammation. That's where you get pain, swelling, and fibrosis. And so we develop this unhealthy fat in different areas of the body as described here. But in lipedema, and specifically in subcutaneous fat, is protective from those metabolic complications until it gets to a certain point, until it starts to result in that unhealthy visceral fat formation and that unhealthy adipose tissue. So we're less likely to see the diabetes, the hypertension, the high triglycerides, the low HDL, fatty liver, gout, even sleep apnea, because of where that fat is located. So it actually plays a health benefit in terms of metabolic disease, but it creates another complication with non-metabolic disease, such as the effect of mass. So you're going to more likely to see knee problems and those types of conditions associated with it. But my point here is that body fat plays a very important role in our health, and that it plays also a very important role in regulating our appetite, and that excess body fat is going to result in metabolic dysfunction when it is not subcutaneous excess body fat when it develops in other areas. And the amount of fat that we need to get to that point is going to vary widely from person to person. We see in Asian populations that's less likely that you develop metabolic complications at lower numbers. So lipedema involves a expansion of subcutaneous tissue, which is less likely to cause metabolic dysfunction. And that's the end of my talk.